Okay, so this question I'm going to walk you through the view an example solution or response that's given. It says according to a recent poll, 29% of adults in a certain area have high levels of cholesterol. They report that such elevated level could be financially devastating to the region's healthcare system and are a major concern to health insurance providers. According to recent studies, cholesterol levels in healthy adults from the area averages about 215 milligrams per deciliter with a standard deviation of about 25. And they are saying that those are roughly normally distributed. If the cholesterol levels of a sample of 51 healthy adults from the region is taken, we have 4 questions to answer. The first part is, what shape will the sample distribution of the mean have? Now, if the recall the following definition of sampling distribution model of the mean. When a random sample is drawn from any population with mean mu and standard deviation sigma, its sample mean y bar has a sampling distribution with the same mean mu and whose standard deviation is given by sigma divided by the square root of n. So this sentence here really gives you the heart and soul of that question. So the shape is going to be the same as the normally distributed standard deviation for the information that was given. Alright, so it will be normal as long as the sample size is large enough, which we will just have to assume that it is large enough for us to be able to move forward with that. Since the random sample comes from a population that is normally distributed, the sampling distribution of the mean will also be normally distributed. What is the mean of the sampling distribution? Again, if you refer to what we just spoke about, the sampling distribution will have the same mean as the population. So that's going to be 215 milligrams per deciliter. If we are asked to find the standard deviation is going to be found by calculating the standard deviation of the so sigma is given the standard deviation of the sample, and n is 51 in the first instance. And real quick, let's change this to 51. This calculates it for us. This is finding the n, which is b1 divided by b2, which is, sigma, which is b1 divided by b2 raised to the half, which is the square root. So we're really employing this formula here in this Excel sheet to come up with 3.507, which is exactly what they come up with here. So you can do this with a calculator or in Excel, as I showed you. The last part is asking you to get a sense of, if we increase the sample size to 110, what would be the difference in answers A to C? Now real quick, remember that the sampling distribution will have the same shape as the population as long as the sampling size is large enough. So increasing it from 51 to 100 will have it even get closer to being normally distributed, so it's not going to cause a change. Part B, the mean will always be the mean of the population. So the mean of the sample will always be 215, even if you change n to 100. And in this case, where we change n to 100, certainly if you go into here, and let's just do this. I'm gonna copy this everything here. This is still 25. If we change this to 100, you see that the new value plummets to 2.5. So increasing n decreases your standard deviation, and the actual value it goes down to is 2.5 once you plug it in to this equation here. Alright, for some reason this is 2.5 and this is 2.38. Oh, I'm sorry, this is 110. That's a mistake I made, I'm sorry. So 2.38, so the answers are the same. I was wondering why they were different. The actual number we increased it to is 110. I was saying 100. It doesn't change the response to A and B, but it changes the response to C. Alright, so sorry about that confusion. So go through. You actually have access to this, so I went through it pretty quickly. But if you want to see it, really all you're doing is clicking on the View and Example tab when you have accessed this question. Alright, so if you have any questions on this, feel free to reach out to us. Alright, thanks, bye.